Hello students, I hope all of you will be fine. So this is our question 3.63, in which we have to find the equivalent resistance of this circuit seen by the source of 20 volts, and in part B of this question we have to find the power developed by the source. So in order to find the equivalent resistance of this circuit, first we have to look at this circuit very keenly. So we can see here that these two resistors and these two resistors, we can see that this the amount of the current flowing through these resistors, these two resistors, and then these two resistors is same. The current of I is flowing through 502.5 kilo ohm are same, while here at this end the current flows through the 1.8 kilo ohm and 1.2 kilo ohm is same. So we can draw it very easily by adding them together. 502.5 kilo ohm are in series, and similarly 1.2 kilo ohm and 1.8 kilo ohm are in series. So by writing them in the equivalent form, at this end, this is our source branch, which is this one. These are our two other branches. Okay, this is 300 ohm, this is the 750 ohm, and on the other hand we have here these branches where this one is connected, also this one is connected. This is 250, this is 20 volts, this is 3 kilo. Similarly, when the other two resistors are added together, because these are in series, we will get them like here, a single resistor of value 3 kilo ohm. This is basically 1 kilo ohm. Here this one is 2 kilo ohm, and similarly this one, when 1.2 and 1.8 k are added, this is again 3 kilo ohm. So this is our circuit in which the series resistors are added together. So now we can see here that the two ends of 3 kilo ohm and 1 kilo ohm are connected to each other. Similarly, at this end, the two ends of the 2 kilo ohm and 3 kilo ohm are basically connected with each other. So we can easily draw this circuit again like this one. This is again our source of 20 volts. This is a 250 ohm resistor, this is a 3 kilo ohm resistor. Similarly, this one is a 750, and this is a 300 ohm resistor. The other two resistors are here. This is a resistor of 1 kilo ohm, and similarly the other resistor with which two ends are again connected with the other two ends of this resistor are this one. 3 kilo ohm is again connected here. Similarly, at this end our resistor is this 2 kilo ohm, and the last one here is this one. This is our 3 kilo ohm resistor. So we can easily see this circuit like this one, that here we have the two parallel combinations which are here and here. So these are again in parallel. So in order to find the parallel combination of these two, let us call it R1, and let me write it here, and in R1, 1 kilo ohm is in parallel with the 3 kilo ohm resistor. So to find their values, 1k multiplied by 3k divided by 1k plus 3k, this is equal to 3k multiplied by k divided by 4k. So when it is cancelled out, this is equal to 750 ohm. Similarly, the other resistor, which is the equivalent of the parallel combination of 2 kilo ohm and 3 kilo ohm, we can write it like R2 is equal to the parallel combination of 3 kilo ohm and 2 kilo ohm and 3 kilo ohm. So it would be equal to 3 kilo into 2 kilo divided by 2 kilo plus 3 kilo, and it would be equal to the 6 into k by 5k, and ultimately we will get 1.2 kilo ohm. This is R2 and this is R1. So writing it here again, this is a resistor, this is the other one. Okay, so now the parallel combination, here we will have R1 here, and here we will have R2, which is already calculated. Okay, this is R2, this is 300, this one is 750, this is 250, and this is a source of 20 volts, and again this is 3 kilo ohm. Okay, so the values are already calculated for the R1 and R2. The value of R1 is equal to 750 ohm, and the value of R2 is 1.2 kilo ohm. Okay, so now here we can also see that this resistor and this R1, these are in series with each other, because the same amount of current is flowing through these two resistors. Similarly, on the other hand, when the current flows here, the 300 kilo ohm and 1.2 kilo ohm are again are in series with each other. So taking the equivalent of these two by adding the 750 with 750 and 300 with 1.2 kilo ohm, we will have an equivalent circuit which can be seen like this one, this is, and this one. So this is the addition of 750 and 750, which is 1.5 kilo ohm. This is the addition of 300 and 1.2 kilo ohm, which is 1.2 kilo ohm is 1200 ohm. So 1200 plus 300 is almost 1.5 kilo ohm. This one is the 250, this is 20 volts, and this one is the 3 kilo ohm resistor. So this is our equivalent circuit, and we can see here that when the current comes here, let me write it in red. When current comes here, it basically divides into two paths. This is I and this is I2, this is I1. So these two resistors are basically in parallel with this branch, so we can easily convert it into another form, which is like, let me go down. Okay, so we can easily convert it into this form, in which the source will be here. Okay, and the two resistors will be connected in parallel with each other. This is the 250 ohm, this is the 20 volts, and this is 3k, and this one is the 1.5 kilo ohm and 1.5 kilo ohm. So we can easily see that here I is, when I comes here, it divides into two currents, which are I1 and I2. So the same circuit can be drawn like this one. Okay, so now we can see that this and these two are in parallel with each other, and the combination of the two resistors which are in parallel with each other, their equivalent will be the half of any one of the resistors. Okay, so this is, sorry, this is 1.5k. so writing it in its equivalent form, this one, and this one. So 1500 divided by 2 is 750 ohm. This is 250 ohm. This is the, so this is our circuit in which we have this 20 volt source, 250, 750, and here we have another resistor of 3 kilo ohm. So we can see that this 250 ohm, 750 ohm and 3 kilo ohm, these three are in series because the same amount of current is flowing through these three resistors. So adding in series combination, we have to add the values of the resistors to find the equivalent resistance in series combination. So writing them in the equivalent form, we will have this, and the last resistor, which is the addition of 750 plus 250 plus 3k, this is equal to the 4k, and this one is the 20 volt resistor. So this is the circuit which we wanted to find out. This is the equivalent circuit, and the equivalent resistance is the 4k, which is shown by the, which is seen by this voltage source. So in order to find the power generated or delivered by this source, that is equal to the power generated by 20 volts is equal to V square divided by R equivalent. The value of V square is 20 whole square divided by 4k, or this is the 400 divided by 4k, or 100. So it will be equal to 100 milliwatt. Okay, so 100 milliwatt is the power which is provided by this source, voltage source, this power source. So now we have find out all the required results which are needed here. So this was our circuit in which we were told to find the value of the equivalent resistance, which is seen by this voltage source. For that we went from here to right here. So here this is the equivalent circuit. From this equivalent circuit, at the end we have find out the value, which is the value of the power which is provided by the source, voltage source. Thank you so much. So this is the end, and this is the end of this chapter as well. We will start the chapter 4 in our upcoming videos. So thank you so much and happy learning.